Welcome to the deep dive. This is where we really try to cut through the noise and get you properly informed on the topics that matter. Today, we're diving into something maybe a bit behind the scenes, but it's actually super important for, well, our daily safety, global health, and key industries. We're talking flame photometric detectors, FPDs. We've got some really interesting source material here, including reports like the Flame Photometric Detector Market Forecast and Trends from Cognitive Market Research. And our mission today, it's really to get a handle on what FPDs actually are, why their market is set to more than double, and maybe most interestingly, where the surprising growth spots are popping up around the globe. Some of the regional stuff might surprise you.
Yeah, it's a great example, actually. It shows how these technologies, which seem kind of niche, are really fundamental to bigger shifts in society.
Yeah.
Things like the rising standards for environmental protection and health safety. These detectors are right there doing the essential work.
Okay, so let's start with the basics then. For anyone maybe hearing this term for the first time, what is a flame photometric detector? What does it actually do?
Right, so fundamentally, FPDs are highly sensitive analytical instruments. And they're selective, too. Their main job really is to detect and accurately measure specific elements. We're mostly talking sulfur and phosphorus, but also other what we call heteroatoms, basically, atoms that aren't carbon or hydrogen inside complex chemical stuff. Think of them like super specialized chemical sniffers. They can pick up even tiny, tiny amounts.
Okay, incredibly specialized sniffers. I like that. So they're very precise. But how does that precision, help us? Where do these things make a difference in the real world?
Oh, all over the place, and in really critical areas. For example, in petrochemical testing, making sure fuels are safe and meet quality standards.
Hmm.
That impacts everything from engine performance to, pollution. Then there's pharmaceuticals.
Yeah.
They're vital for quality control,
Mm.
ensuring medicines are pure.
Right. That's crucial.
Absolutely. And food safety, too, detecting contaminants. And maybe one people connect with more easily, environmental monitoring,
Wow.
measuring pollutants in the air, in water.
Okay.
Yeah, the common thread is this growing need for super accurate detection, even really small amounts in complicated mixtures.
That kind of precision sounds expensive, though, or maybe complicated. Why FPDs? What makes them, the go-to choice compared to other tools out there? What are the advantages?
That's a fair point. A few things make them stand out. First, they're actually quite cost-effective to run, which matters for labs. Plus, they give you really fast results. Quick response times are key when you're testing a lot of samples.
Speed matters.
Definitely. And they have enhanced detection capabilities, especially for elements that are volatile things that might be tricky to measure otherwise. They're reliable, efficient.
Mhm.
That's why industries depend on them.
Okay, let's unpack this then, because you mentioned the market, and the numbers here really tell a story. What's the overall picture?
It really does. So back in 2021, the global market for FPDs was valued around $651.55 million.
Okay.
But the projection is where it gets interesting. It's expected to more than double by 2033, hitting about $1,413.7 million.
Wow, double.
Yeah, and that works out to a compound annual growth rate, the
Mm.
CGGR, of 6.668%. That's pretty healthy, steady growth year over year.
That is a big leap, clearly not just happening by chance. So what's really driving that surge? Is it just those safety standards you mentioned earlier, or is there more to it?
Well, those rising standards, environmental, health, safety, they're definitely the big umbrella driver, you could say, but that translates into very specific demands. The growth is directly linked to needing more precise analytical tools across all those sectors we touched on.
Petrochemicals, pharma.
That's exactly. Petrochemicals, pharma, food safety, environmental testing. Countries and companies are just investing more. Building refineries, scaling up drug production, tightening food safety checks, expanding environmental monitoring programs. And all of that requires more FPDs, and often better, more sensitive FPDs, to meet tougher rules and guarantee quality.
Now, this is the part I found really fascinating when we looked at the data, the geography of it all. Where is this growth actually booming? Any surprises?
Yeah, the regional breakdown is pretty revealing. Let's start with North America. It's the biggest market right now. We're looking at revenues climbing from roughly $259 million in 2021 to over $500 million, $539.87 million by 2033.
Big numbers.
Right. The U.S. is the leader there, no surprise,
Right.
with all its research labs and strict environmental rules. That's growing at about 6% CAGR.
Okay.
But interestingly, Canada's actually growing faster at over 7.4%. That seems fueled by their expanding pharma and food safety sectors, and Mexico too, showing strong momentum around 6.6% CAGR. That reflects, industrial testing standards getting tougher across Latin America.
Okay, North America looking strong. What about Europe? We always think of Europe having really tight regulations.
And you'd be right. Europe's market is definitely flourishing. It's expected to hit over $264 million by 2033. And yes, that's absolutely supported by strict EU environmental rules, plus a lot of tech innovation happening there.
Which countries stand out?
Well, you see strong performance places like France growing over 7% and Luxembourg around 6.9%. But maybe the most interesting bit is the rest of Europe category. That segment's actually growing the fastest, nearly 8% CAGR.
Ah, so growth beyond the usual suspects.
Exactly. It suggests wider adoption, maybe catching up on regulations or new industrial investments across the continent, not just in Western Europe.
Okay, let's pivot to Asia Pacific. Always a dynamic region. How's the FPD market shaping up there?
Oh, Asia Pacific is definitely one of the hottest spots for growth. Huge potential. The market there is projected to go from about $123 million in 2021 to over $286 million by 2033.
Also more than doubling.
Yep, and the drivers. Rapid industrialization, for one, plus big increases in investment in chemical testing labs and regulations getting tougher across the board.
Any specific countries leading the pack?
India is seeing really explosive growth over 8.2% CAGR, Singapore too, around 8%, and Southeast Asia as a whole, nearly 7.9%. They're all seriously upgrading their analytical capabilities.
Makes sense with all the manufacturing and development there. Now, I'm really curious about other regions, places maybe we don't always focus on in these global market talks. Any surprises further afield?
This is where it gets, I think, really remarkable. The Middle East and Africa region. Now, the starting market value is smaller, okay, but the growth potential is extraordinary. Specifically, Africa. Africa is projected to have the highest TJR globally. We're talking 10.61%.
Wow, over 10%. Why so high?
It signals massive untapped opportunities, especially in environmental monitoring and healthcare diagnostics. It suggests, maybe a leapfrogging effect. Nations like Nigeria, South Africa, both seeing growth over 10.4%, even 10.6%. They're adopting advanced tech, perhaps skipping older methods.
So investing heavily in environmental and health infrastructure.
Exactly. It looks like a fundamental investment in public health, in sustainable industry. That's driving this incredible FPD adoption rate across the continent. The rest of Africa segment shows similar high growth, too.
That is a surprising statistic. Very interesting. And what about South America? Are they part of this trend too?
South America is definitely seeing strong growth as well. Maybe not quite Africa's level, but significant. Countries like Colombia, around 7.4% CAGR, and Argentina, about 7.2%, are showing notable momentum.
And the drivers there, similar themes.
Yeah, pretty similar. Governments boosting infrastructure for things like pollution control, making sure industries comply with regulations. It's part of that same global push for better measurement and oversight.
So we've seen where the growth is happening. Looking ahead, what does this all mean for the FPE technology itself? How is it changing to meet all this demand?
Good question. The tech isn't standing still, that's for sure. There are several key trends shaping things. One big one is miniaturization, making the detector smaller, more portable. That opens up uses in the field or in labs with less space.
Right, more flexible.
Exactly. Another is tighter integration with other systems, especially gas chromatography or GC. GC systems basically separate complex mixtures out first, so the FPD can then analyze the individual components much more effectively. That combination is really powerful.
Enhances the whole process.
Greatly enhances it, yeah. And then just ongoing improvements in the detectors themselves, making them more sensitive, more selective, picking up even lower levels of things, distinguishing between similar compounds better. We're also seeing a big push towards real-time monitoring, more automation in the testing process, and linking up with cloud-based tools for data analysis and storage.
So faster, smarter, more connected.
You got it.
Yeah.
And all these innovations, they just make FTDs more efficient, more useful, more indispensable, really. It fuels that demand cycle we talked about.
It's really something, considering how these tools operate largely unseen. This deep dive really underscores that FPDs aren't just some niche lab gear. They're actually fundamental to, well, guaranteeing safety and quality in so many areas that touch our lives. The air we breathe, the food we eat, the medicines we take.
Absolutely. And as those global standards for environment and health keep climbing, which they certainly seem to be doing, the FPD market is just going to become an even more vital piece of the whole analytical instrumentation puzzle. It's creating growth opportunities everywhere, developed countries, emerging economies. It really underpins the trust we need to have in, well, everything around us.
So maybe something to think about as you go about your day. Just consider how much relies on this kind of unseen precision, from making sure your medicine is pure to checking the safety of the environment, and how technologies like these flame photometric detectors are constantly evolving, getting better, quieter, faster to meet challenges we might not even know exist, shaping our world in ways we rarely notice. Welcome to the Deep Dive. This is the show where we take your sources, unpack them, and pull out the key insights for you. Today, we're looking at something maybe you haven't heard of directly, but it really does affect a lot. Flame photometric detectors, FPDs.
Right. They're kind of behind the scenes, but crucial.
Exactly. So our mission today is to explore what's driving their market, the trends, the challenges, and figure out why this seemingly niche tech is becoming so vital. At their heart, they're these super sensitive detectors, mostly used in gas chromatography. That's the technique for separating stuff in gas mixtures.
Splitting things up to see what's inside.
Yeah, and FPDs are really good at sniffing out sulfur and phosphorus compounds specifically. Okay, let's unpack this. So, first off, why the surge in demand? What's pushing FPDs forward right now? Our sources point strongly to industrial demand.
Definitely. Petrochemical natural gas analysis. They're huge areas.
They seem indispensable there, like for quality control in refineries, making sure fuel is pure, checking natural gas quality.
Yeah, it's all about monitoring those trace contaminants. Things you really don't want in there.
For purity, but also for safety, right?
Absolutely. What's fascinating here is how this connects to the bigger picture. It's not just about hitting a spec sheet. It's fundamentally about safety and process efficiency. That high sensitivity, especially for something like sulfur, is critical. It's like an early warning system for potential problems in these huge industrial processes.
That makes total sense. And it's not just the demand side. The tech itself is getting better, isn't it?
Oh, massively. The advancements in chromatography, and specifically FPDs, have been significant.
We're seeing things like better signal-to-noise ratios, so clearer results, basically.
Exactly. Like hearing a faint instrument in a loud orchestra. And lower detection limits, they can spot even tinier amounts now.
Plus, they integrate better with digital systems, making them, I guess, more reliable, smaller.
And just easier to work with. More user-friendly. That's actually a really big deal because it means they're not just for the super specialized labs anymore.
Right, it broadens the potential user base.
Which ties perfectly into the next big driver,
Yeah.
regulation.
Ah, yes. Stricter environmental rules. That seems to be a constant theme across industries.
It really is. Governments everywhere are tightening the screws on emissions, particularly sulfur emissions, for air quality.
And FPDs are sort of tailor-made for that specific job, identifying and measuring sulfur from industrial sources like power plants or refineries.
Precisely. If you need to accurately monitor sulfur to meet regulations, FPDs are often the go-to tool. It shows how environmental concerns directly fuel technological uptake.
Okay, so strong demand, better tech, regulatory pressure. Sounds like a winning combo. But it can't be all straightforward. What are the bumps in the road?
Well, nothing's ever that simple, is it?
Haha, true. One thing that comes up is maintenance. These things need pretty precise flame conditions.
They really do. That flame is the core of the detection mechanism. So regular calibration is non-negotiable if you want accurate, sensitive results.
And that level of precision and upkeep. It can be tough for smaller labs, right? Or places without dedicated technical folks.
Definitely. It requires a certain level of expertise and commitment to maintain them properly. This raises an important question. How do you make such precise technology accessible and practical across the board? That maintenance need can absolutely be a barrier, particularly in, say, emerging markets or smaller facilities where resources might be tighter.
And they're not operating in a vacuum. There's competition from other detection methods too, isn't there?
Oh yeah, mass spectrometry is a big one.
Mhm.
Then you have things like thermal conductivity detectors, electron capture detectors.
And some of those can detect a wider range of compounds, not just sulfur and phosphorus.
That's often the case, yes. So depending on what exactly a lab needs to measure, they might choose an alternative that offers broader capabilities.
Makes sense. Trade-offs.
It is. But the key advantage for FPDs, their unique selling point, remains that incredible specificity and sensitivity for sulfur and phosphorus. If that's what you primarily need to find, especially at low levels, they're often still the best choice.
Okay. And the last challenge mentioned is, well, just awareness. People not knowing about them.
Sort of, yeah.
Hmm.
In the traditional fields, like petrochemicals, they're very well known.
Hmm.
But in newer areas, or maybe labs just starting up,
They might not be aware of FPDs or their specific advantages for certain tasks.
exactly. It's a classic challenge for specialized tech. If potential users don't know you exist or don't understand why you're better for their specific problem, adoption will naturally be slower. Education becomes key.
Okay, so challenges are there, but looking ahead, what's getting people excited? What are the big trends? Here's where it gets really interesting. Automation seems huge.
Integration with automated systems, yes. That's a major push across all analytical chemistry.
So, hooking FPDs up to robotic systems that handle the samples and run the analysis.
Precisely. It massively increases throughput, how many samples you can run. Think high-volume labs needing continuous, real-time data,
Less manual work, faster results.
and often more consistent results too.
Hmm.
If we connect this to the bigger picture, automation is about efficiency, reliability, and scaling up analytical capabilities. It lets labs do more faster.
And then there's miniaturization, making
Yeah.
them smaller, even portable.
Yes, this is incredibly exciting. Developing compact FPDs you can actually take out into the field.
Wow, so on-site analysis, not just sending samples back to the lab.
Exactly. Think environmental testing right at the source of a potential problem. Or emergency response, quickly assessing air quality after an incident. Mobile labs even.
That feels like a potential game changer, bringing the lab to the sample.
It really is a paradigm shift. It allows for much faster decision-making when time is critical.
And finally, a trend that maybe hits closer to home for a lot of us, food safety.
Mm-hmm. Agriculture and food residue analysis. This is a growing application area.
Because of stricter food safety standards globally, needing to detect tiny amounts of pesticide residues, for example.
That's a big part of it, specifically sulfur-containing pesticides, since FPDs are so good at detecting sulfur.
And they're becoming a valuable tool for analyzing food samples and monitoring crops.
Precisely. It really demonstrates the versatility of the technology beyond its traditional industrial roots. It's directly contributing to public health by helping ensure our food is safe.
So what does this all mean? When you pull it all together, we've looked at FPDs, seen the push from industry, the boost from tech improvements, the pull from regulations.
Right. And also the hurdles, the maintenance, the competition, the awareness gap.
But then these really powerful trends emerge. Automation making things faster, miniaturization making them portable.
And new applications like food safety, showing their adaptability.
It really highlights how these specialized technologies, which most people never think about, have this profound impact. On industry, sure, but also on the environment, and yeah, even the food we eat. It connects back to everyday life in ways you might not expect. Which leaves us with a final thought to chew on. As detection tech like FPDs gets smaller, more automated, more portable, how might that revolutionize our ability to monitor things, to analyze and ensure safety basically in real time everywhere?
It's a powerful question. The potential for near-instant understanding of our environment, our processes, our products. It's quite transformative.
Definitely something to think about, how that real-time, ubiquitous analysis could change things.